Hi, this is Mr. Beck does your homework. This is AP Physics homework number 25, and this is about rotational kinematics. This says initially a wheel rotating about a fixed axis at a constant angular deceleration of 0.6 radians per second squared. Let me make that my alpha. My angular acceleration is negative 0.6 radians per second squared. It has an angular velocity of 0 radians per second. So that means that my angular velocity is 0 radians per second. So it's initially at rest. And an angular position, so its initial angular position is 9.1 radians. It's saying, what is the angular position of the wheel after 3.3 seconds? So I'm looking for its final angular position after a time of 3.3 seconds. Now, what I think is the easiest way to do that is figure out the change in angular position using the other variables and then subtract that change from here. And why I'm subtracting is because this is going to be negative. So it's going to go through a negative angular displacement. And so with an initial angular velocity and an acceleration and a time, I can figure out my change in position is going to be my initial angular velocity times time plus 1/2 the angular acceleration times time squared. So that'll give me my change in angular velocity. And so that's going to be my initial angular velocity of 0 times time. Well, that's easy. Plus 1/2 of my angular acceleration. For me, that's negative 0.6 times the time squared, 3.3 squared. So if I calculate this, this will give me my change in angular velocity, and it's going to give me some negative value, and that's going to be in radians. And if I know that my final angular position is going to be my initial angular position plus whatever my change in angular position is, well, this is going to be a negative value. And so I can actually plug that right in as a negative value. And so what this is going to be for me is that my final angular position is going to be 9.1 plus this negative value. So this is going to be a negative value in here. And so that's going to give me my final angular position. So if that change was negative 20, then I'd wind up at about negative 11 or so. So just be very careful. This is a positive value, and then you're adding a negative value. So you're basically subtracting that value to get your final angular position.